All right, so here's my take on the firmament. Now it says, having a solid, almost unyielding surface or structure. Now, technically nothing in the universe is actually solid. Everything is moving in a fluid manner. But I'll get to that. Strongly felt and unlikely to change. That means it's consistent and it's very obvious. A mint, couldn't really find much on that. It pretty much means damn near everything. Mental illness, a thong, it's a catkin in botany. A change or variation occurring in the course of something. But I'm digressing. Anyway, it's the Carman line. And basically, the Carman line is 54 nautical miles or 62 standard miles. And imagine, that's why I made this a thick line around here. That would be the Carman line. That would be our whole atmosphere where basically it ends and then there's the void of space. And that's basically the Carman line. Now, if someone says, oh, well, you can't trust all this, it's all digitized. Everything that we have is digitized. So anyone that gets their information from somewhere, they're going to have to, find it where it's not digitized somehow. This very video is digitized, so can't trust that. But the Carman line separates the waters from the waters because we live in a dome of gas or home. It's dense gases and gravity, and the gases are all liquid. Now, to get off of the planet, we need to be slung off of it at least 17,500 miles per hour. We can't float off of it. Now, mercury is technically a gas also, just like water is, and they're both liquids. It just depends on what atmospheric pressure it's at. So it's all fluid mechanics, the laws of motion. So all of these particles, in a large scale, the stars act like particles, and they're fluid. They're moving. So you can imagine all these dots make up one particle. We live in a dot matrix, a fluid dot matrix. Because all particles are moving around at all times. Everything's moving. Even particles that are in a lattice or in a matrix, a dot matrix, in a lattice, like glass. Glass is technically still moving in that lattice on a very, 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 very tiny, quantumly small scale. There's still fluid going on. And even if it's solid and they're not moving slightly, it's still vibrating. All those particles are still moving around and vibrating that make the lattice, that make up whatever molecules you have. And the thermohaline is part of this because the salt waters are cold and there's warm, and there's more salts and there's less salts. And if you have cold, more salt, you have denser water because it's cooler, and you have more salt. And all these particles are going to be condensed on a very small scale, and it's going to act like a wall. So then the warm waters that are more expanded aren't going to be able to mix well with it because now this cold dots of coldness are acting like a wall. So it doesn't want to mix well. And look, the buoyancy, the reason things float up is because of density and buoyancy, yes. But ultimately, once it reaches the Carman line, this out here, the void, can't just suck it up, no different than the water adhering to it and causing friction, and the gravity of everything that's part of this part of the atmosphere. Our whole atmosphere has more energy, and since you're a part of it, it's not going to pull you out. It can't pull someone out. They have to use escape velocity to get slung out. That's why once you float to the top, the air around you that you're breathing doesn't just pull you out of the water and you get sucked into space. It's no different. You can imagine this is the Carman line in this aspect. So technically, it doesn't have to be solid because technically nothing in the universe is actually solid. It just depends on what perspective you're looking at it from. And the only way you can get slung off is by creating an anti-gravity effect that can breach the Carman line. So the Carman line, gravity, density, buoyancy, all of that ties together, obviously. And it all ties together through electrostatic polarity. So let's say these dots right here are a lattice of matter, and there's like 9 atoms. Let's say there's 900 atoms. And then this mass of matter, you have 12 or 1,200 atoms. Now this imbalance of electrons is a type of electrostatic because there's an imbalance of charge. So you could say this one is denser. It has more matter and energy in it than this one.